Okay, welcome to the second revision video for Unit 1. Today we're looking at displaying and interpreting data. So as before, please can you copy down anything in black and anything in blue or red. You can decide whether to copy that down or not. So, let's start by looking at some scatter graphs. So, here's an example of a scatter diagram. Please don't draw this diagram. I think we all know what a scatter graph looks like. So let's say that there was going to be another point added, that when there was 45 millimeters of rain, it was 12 degrees centigrade. Then we can just put another point on the graph. We go up from 45 along to 12, and we should get another mark on the graph just there. Hopefully scatter diagrams are something that we're all very familiar with. Okay, one thing we do need to see is correlation. Correlation is a way of measuring the distribution of the data, what sort of patterns we can get from it. So here are three different examples. Please copy down each of these and we'll look at each of these in turn. The first of these is called positive correlation, because it goes up from the bottom left to the top right. That makes it positive, and we say it has strong correlation because all the points are quite tightly clustered together. Then our second example, well, that one goes down from top left to bottom right. So we say this one has strong negative correlation because it goes down, negative correlation. And finally the last one, well, the points are all over the place here, so we'd say it has no correlation. We can't find any pattern in the data. Okay, if we have a graph which does have fairly good correlation, we can draw a line of best fit. Now a line of best fit follows the trends in the data, so we want to have the same number of points on both sides of the line of best fit. Okay, stem and leaf diagrams. So here we have a set of results for a statistic test taken by 11 students. We want to put these into a stem and leaf diagram. So for a stem and leaf diagram, we obviously need a stem and a leaf. Okay, we need to choose numbers for the stem so that the leaf only has a single digit. So looking along, we want to have our stem as 3, 4, 5, 6, 7, so that to get any of the numbers in the data set, we just have to write a single number in the leaf. Okay, so let's do this now. So we start with 3, so we got 38. We have 4, so going left to right we have 40, 45, and that's it. Looking at the 50s, we have 58, we have 54, we have 58 again, and we have 51. Then the 6s, 66, and 67. 70s, 78, and 73. Right, at the moment, all the data is in any old order in the leaves. So what we need to do now is to try and order that data. So this was our rough stem and leaf diagram. We're now going to do a neat one over here. So same basic layout. We once again have our stem and our leaves, and the same numbers in the stem, but this time we're going to make sure that the numbers are in order in the stem, working from smallest to biggest. So the first row is going to stay the same, the second row also stays the same, the third row, going from smallest to biggest, we have 1, 4, 8, 8, and then 6 and 7, and 3 and 8. We're nearly done now. All we need is a key. So our key for this one, 3, 9, 8 means 38. That's everything we need to do when we're drawing a stem and leaf diagram. So here's our same stem and leaf diagram. I've just tidied it up a bit, and now we want to find a few different aspects. So first of all, let's find the range. Now to find the range, all we need to do is take the biggest number, 78, and subtract the smallest number, 38. We'll find these at either end of our stem and leaf diagram. So the range in this case is 40. To find the median, we need to halve the number of pieces of data, which in this case is 11, plus 1. So 11 plus 1 is 12, half that, we get 6. So we want the 6th piece of data. So counting through, starting at the smallest, we have 1, 2, 3, 4, 5, 6. So the median is not just 8, the median is, that's right, 58. To find a lower quartile, we want to do something very similar. As it's quartile, we want to find a quarter of the number of pieces of data plus 1. So 11 plus 1 is 12. Find a quarter of that. That is 3. So we want the third piece of data. So this time, we've got 1, 2, 3. So it's going to be number 45. Similarly with the upper quartile, this time we want 3/4 of 11 plus 1, which we can work out is the 9th piece of data. So let's find that. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 67. Of course, we could also find that one by counting back 3 from the biggest number. That gets the same answer. And then to find interquartile range, we just take our upper quartile and take away the lower quartile, which will give us 22. Okay. We can also put two stem and leaf diagrams together back to back like this. This allows us to compare the results for boys and girls in this case. Here, note that the girls' stem and leaf diagram actually seems to be back to front now. So for line 3 actually means 34 because the 30 is still the number in the stem. So we can work out a few bits of data for both of these using exactly the same method as we did on the previous slide. We can work out that the median for the girls is 47 and the median for the boys is 54. Their ranges are 24 and 40. The upper quartiles are 54 and 59. The lower quartiles are 41 and 46. And so the interquartile range are 13 for each of them. Then if we're asked to compare this data, we can draw a few conclusions. First of all, we can say that the boys' median is 7 marks higher than the girls'. The interquartile range is the same for both boys and girls, and the range of marks for boys is much greater than the range of marks for girls. Okay, so let's leave stem and leaf diagrams now and go on to the last part of the topic, box plots. So here we have the results of 15 students in a science test, and we want to put this into some sort of box plot. So the first thing we're going to do is we're going to take all this unorganized data and we're going to put it in order. So there we have it, all their information in order. So once we have that, we can then work out the range, the median, upper quartile and lower quartile. So the range, once again, is just going to be the biggest number, take away the smallest, which is 44. The median, we want to find the middle number. Well, we know there's 15 pieces of data, so we want to find half of 15 plus 1. Well, 15 plus 1 is 16, half of it is 8, so we want the 8th piece of data. So counting in from one end, 1, 2, 3, 4, 5, 6, 7, 8. we find the median is 52. The upper quartile, well, to find that, we want 3/4 of 15 plus 1, which is the 12th piece of data, reading from the smallest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is 64. And the lower quartile is 1/4 of 15 plus 1, which is the 4th piece of information, which, counting along, 1, 2, 3, 4, is 41. We now have enough information to actually plot our box plot. So we know the median is 52, the range is 44, the upper quartile is 64, the lower quartile is 41. So we're going to draw a line where we have our median. We're going to draw another line for our lower quartile. Another one for our upper quartile. And we're going to join up these lines we've just drawn into a box. So that gives us the box part of it. We then need to know the smallest points, which we know is 36. And the biggest points, which we know is 80, which has gone off my diagram. 80 is up there. And we just join those up with a line. Okay, and that gives us our box plot, sometimes known as a box and whisker plot. And that's everything in displaying and interpreting data.